Today's notes are on absolute value, so you want to have your solving absolute value equations notes template out, and the top part would look like this picture here. We're going to take a look at some details of absolute value. The symbol for absolute value is just two straight bars. And the rules for absolute value is always positive or zero. Because it's distance from zero, and distance can't be negative. And that is based on the definition being the distance from zero on a number line. So distance a number is from zero. So examples in the symbols, you could have the absolute value of a negative value, the absolute value of a positive value, and you can have absolute value of zero. When you're solving equations and we're looking at solutions, you could have the absolute value of something would be equal to a positive real number. So that would mean that you have two possibilities. You would have a negative number and a positive number. If your value inside the absolute value is equal to a negative real number, then you have no solution, or the empty set. Or if the absolute value of x is equal to 0, then the solution would be 0. So when we have an absolute value equation, it's going to either have two solutions, no solution, or a solution of 0. Those are our only choices. When you solve an absolute value equation, you want to get the absolute value by itself. Now, a lot of times we'll refer to that by the word isolating. So you isolate the absolute value. It just means to get it by itself. Taking the absolute value, finding that distance from 0, is the last step. So that's really important. You have to get the absolute value alone, and then you take the absolute value. So for our first example here, we have the absolute value of x plus 6 is equal to 10. So we want to isolate the absolute value. So just like when we're solving, we want to get x alone, we just want to get x, the absolute value of x alone. So to do that in short form, I would add negative 6 or subtract 6 on both sides. The plus 6 and minus 6 would cancel, and I get the absolute value of x equal to, and then on the right-hand side, I would have the number 4. And this is where, okay, I've got the absolute value by itself, so now I take the absolute value. Well, what are the things that would give me an absolute value of 4? Well, that would be that x could equal 4, or x could equal negative 4. And so those are my solutions. And I list my solutions in set braces, and it's best to list them least to greatest. So we'll typically put that negative value first. And we've solved our absolute value equation. So our next example, just a little more complicated. We have a subtraction in front of a value in parentheses with lots of subtraction. So when I've got a lot of subtraction or a couple instances of subtraction inside an equation, I typically want to apply definition of subtraction. So I'm going to do that. Again, short form. I don't need to show the properties, but I do want to make sure I'm following properties as I solve and simplify. So the next step here is I have this opposite and I have a whole sum, so I need to use op sum. Again, I don't need to write that property, but I do need to make sure I'm applying it. So my next line, I'm going to take the opposite of each piece inside the parentheses, and like the first opposite sign outside and this one on the inside, they cancel each other out, and that's my new equation. Now on the right hand side, I can simplify. I have like terms, and so I get 8 is equal to negative 6 plus the absolute value of x. Now I can worry about getting that absolute value of x all by itself. I want to get rid of the negative 6. So I do that by applying ALE on both sides, adding 6 to both sides of the equation. And that gives me 14 is equal to the absolute value of x. And so I'm thinking about, okay, well, what values can x be that would give me an absolute value of 14? Well, x could equal 14, or x could equal negative 14. And so that is my solution set. Again, listing them least to greatest inside the set braces. Getting the absolute value bars by itself, then finding the absolute value. For this next example, I've got a value being multiplied by the absolute value of x. So to undo that, I would multiply by the inverse. So the inverse of negative 4/5 is negative 5/4. So I would take that and I want to multiply by what I had on both sides of the equation. This is an application of MLE, or multiplication law of equality. So again, I just kind of multiplied by the negative 5/4 on both sides of the equation. These two values on the left, the multiplicative inverses, they would cancel because they would give me a value of 1. And so I can kind of exclude that. Multiplying by 1 does not change the value. So I'm just left with the absolute value of x. And then on the right-hand side, I'm multiplying, and I get negative 15 halves. Now you could do that work for that, or you can do that on a calculator. What happens there is I have the absolute value of x equal to a negative value. So again, looking at that carefully, I've got a negative value here. An absolute value is always positive. So if I have the absolute value of something and it's equal to a negative, I know that that cannot be true. And so this is the empty set, or no solution. So you would either say no solution with the empty set symbol, or you could show the set braces with nothing in them. Now you don't want to put the symbol inside the braces. You do one or the other. So your turn is, like it is, pause the video, try to solve this equation, the absolute value of x divided by 3.5 equals 6. And then restart the video and see if you have what matches. So again, encouraging you to pause, try to solve this one, and then check it. Okay, so and to undo dividing by 3.5, we would just multiply both sides by 3.5. And that's an application of MLE. So I'm going to show that on both sides of the equation. These would cancel each other. You could show the steps for that, but you don't need to. That's going to give you absolute value isolated on the left, and on the right-hand side you get 21. So the absolute value of x is equal to 21, and that's going to mean that x is either equal to negative 21 or 21. So hopefully that's what you got. If you did not, make sure you take your questions in to your teacher. Right, the next one is a little more challenging because we've got an equation that is 2 steps to isolate the absolute value. So if you look at like order of operations, you've got something being multiplied by the absolute value and you've got it being subtracted from something. So that's 2 steps to isolating. Okay, so I need to get rid of 2 values here. I need to get rid of the 7 by subtracting 7 from both sides. So those will cancel. That leaves me with the opposite of 3 halves, or negative 3 halves, times the absolute value of A is equal to negative 6. And then to undo multiplying by negative 3 halves, I would multiply both sides by its inverse, negative 2/3 times negative 3 halves times the absolute value of A is equal to, and then of course I have to multiply by the same thing on both sides, keep it equivalent. And those would cancel. I get the absolute value of A is equal to, and here, just doing that multiplying, I've got 12 over 3, which is, of course, equal to 4. So I have the absolute value of A is equal to 4. And that means that my solution is either going to be negative 4 or 4. So to solve this equation, I need to subtract 7 from both sides. Those would cancel. And I would get the negative 3 halves times the absolute value of A is equal to negative 6. I want to multiply by the inverse of negative 3 halves on both sides to kind of undo that part. So I'm multiplying by negative 2/3 on both sides. Again, by negative 2/3 on both sides, got to keep it equivalent. Those would cancel, leaving me with the absolute value of A. This gives me 12/3 or 4. Absolute value of A being 4. And that means that my solution is either negative 4 or 4.